Okay, cool. We're recording, and this is assignment 6. So congratulations, folks. This is the halfway point. It's also an easier lab, right? There's not as many routers as the last one. Congratulations. The only thing is the addition of IPv6. Not a big deal. Not a big deal at all. Routing is the same. Okay, it's just a few more digits. Not a big deal. So here's what we got here. Okay, 10.10.20/22 is over on the left-hand side here. 10.10.10/23. So that's going to give us our 500 hosts, or 510 hosts possible. The /22 is going to sum up, or it's going to summarize 4 Class Cs, right? So 1,000 hosts can fit in there. And check this out. So here we have now, we're going to be a little bit more efficient with our IP addressing in the fact that we're not going to be burning up a whole bunch, right? So router point-to-point links are now /30s, okay? /30 there, /30 down to all of the other routers. 10.30.30, /30, 10.20.30 over on that side. And then the LAN address, 10.20.20. That's a /22 down there. 10.30.20 /22 down here. Now, the what's over here, right? The router point-to-points. You notice that we're keeping everything easy right now. /64s. Right, it's kind of overkill for a point-to-point interface because you're only burning up like 18 quintillion addresses, right? /64s everywhere. So what we're going to do here then, the IPv4 portion is straightforward, right? You probably want to know the subnet mask numbers for /22s, /23s. Right, so /22 subnet mask is should be 252. Right, because here's the class full 16 right here, plus another 6 bits out that way, right? So that is your /22. Your /23's subnet mask is going to look like 254.0. Okay, /30. Okay, and remember what we looked at yesterday. /22 and a /30. They have the same network numbers. They all go in increments of 4. Right? And the more you start working with stuff like this, the more you'll start seeing the patterns. And those patterns become easily recognizable, and those patterns become kind of cool, right? Just like 1010, right? Okay, cool. So here's what we got. IPv4 only. Use last host IP, last host, and then same thing like the other lab next to last for your switch interface VLAN 1. The 2960s, you cannot configure IPv6 on it. That's okay. It'll just pass layer 2 anyway, so that's fine. Okay, last host. Okay, and then for IPv6, use 254. Okay. And this is last host over here, and this is also IPv6 254. Okay, cool. So let's go to desktop here. Okay, so this one's the blank one. It's all copper up here. So let's get this all connected up. Okay, so technically, router is it's a host. Okay, we have Ethernet 000. We have Ethernet 000 up here as well. So why don't we use that for our LA connection? Okay, and fast E0 out this side, fast E1 out this side. Fast E0 out this side. Fast E1 out this side. Okay, let's get our labeling going for 10.10.20.0/22 and 20AB 10.10.20.64. That's on that side. This side is 10.10.10.23. Okay, this side 10.10.30.0/30, 20AB 10.10.30/64. This side 10.20.30.0, and then 20AB 10.20.30.64. This side 10.30.30 and 20AB 10.30.30.64. Okay, this side 10.20.20/22, 10.20.20.64, and 30.20, and then 20AB 10.30.20.64. Okay, so we saved that. Now, our Cisco template here, it's always going to have this IPv6 unicast routing. Okay, this here, let me bring it back here for you. IPv6 unicast routing. This turns IPv6 routing on. And it's kind of dumb, right? In the fact that, yes, you can configure IPv6 addresses all day long on interfaces. You can do it. You just won't be able to route unless you have that one global command in there. It's kind of dumb that the parser will let you configure IPv6 addresses, but you can't route. It's kind of dumb, right? So this is what happens here. Okay, device must be powered on. All right. Okay, I'm going to save this as working. Okay, so to turn IPv6, to turn that all on, it's IPv6 unicast routing. That's your command that's right there. The shortcut, IPvu. That's your shortcut. So I don't know about you, but I'm using the shortcut. Okay, so that means, LA 1841. Okay, we should be good there. Now let's just get our addressing going here. So F00 should be out that side. Link to users, okay. IP address 10.10.20.1. Okay, /22 is going to have that IP there, or that subnet mask. IPv6 addresses now. So it's IPv6 address, right? You could shorten that. You could shorten that to this. IPv address 20AB 10 10 20. And we'll use the first IP. Well, technically it's 0, but we'll keep same. So we'll keep .1 here and :1. Include your prefix length, which is a /64. Okay. Now, there's something else here. For routers, a router is going to, remember we talked about yesterday that a router is going to automatically configure its own link local address, its own LLA. Now, we can use that LLA as the IPv6 default gateway because it's unique and we can shorten it up. And remember too that link local addresses are not routable. They're only specific for this link or for this LAN. Okay. So why don't we do something like we make this 1, 2, 3, and 4, right? And remember, link local addresses start with FF or FE80. So let's do this. Okay, so show IPv6 interface for F00. See, check this out right here. It's going to automatically calculate its link local address as this. Okay, so you notice that this is basically the MAC address, right? FFFE is right in the middle, but the MAC address is this, right? Here it is, 2.177A3501. So you notice, here it is, 17 FFFE 7A3501, right? And then the leftmost, so the 7th bit is flipped, so it flips it to a 2 over here. See how that works? Now, show IPv6 interface. It joined multicast group FF02. Okay, so let's no shut here. And now it joins some more. It joins some more multicast groups, right? Solicited node multicast. So what this is doing here is that it's going out and finding out the neighbors. Okay, and here is our global unicast address, GOA what we're talking about, these are routable. These are routable. These are not routable, right? So any type of IPv6 communication between hosts on a specific LAN are happening at the link local level. Now, to route, that's where global unicast comes in. So keep that in mind, right? Because check this out, for LAPC2, because for LAPC2, let's say an IPv6 host comes online, it can solicit the router. It can ask the router, hey, can you give me a router advertisement? Can you give me the prefix? I'll figure out my host ID, and we'll get communicating that way. So as long as if you have IPv6 unicast routing turned on, and you have a prefix and a global unicast address configured, theoretically, we should be able to go to autoconfig, and guess what? IPv6 autoconfig request successful. Right? So look, it picked up the gateway of the link local of the router that's right there. So let me show you this IPv6 config. Right? Here's the default gateway, which is the link local of the router that we just looked at. Right? And it figured out its own IPv6 address. Isn't that cool? Oh my goodness. So that means, hey, IPv6 host is online. Now, because this, can you imagine asking a user or asking a tier 1 help desk to change somebody's IPv6 default gateway to this? Yeah, that's probably not going to work too well. Like that's a lot of digits, right? So what we can do here is we do IPv6 address FE80:1 link local. So we're going to specify our link local address for the router there to be :1. So next time we come out here to try to slack another IPv6 address, hey, IPv6 gateway. IPv6 gateway is now FE80:1. Isn't that a lot easier? So that means we need to go down to this side. So let's do interface F01. This is our link to servers. Okay, IP address 10.10.10.1. Okay, IPv6 address 20AB 10.10.10.1/64. Now, this will allow you, IPv6, it allows you to stack on a whole bunch more. You don't have to do this, I'm just demonstrating it. Right, so let's say if you did, I don't know, maybe fat finger a IPv6 address like this, like what Professor did on purpose. You have to take those out manually. The way you do that is like this. Just put a no in front of it. Okay, so that was up here, right? So no IPv6 address, and it'll take it right out. See? Okay, so let's no shut here. Oh yeah, IPv6 address FE80:1, link local. Now notice here, we can use the same link local on every router interface. So this is router specific, right? So we can make it that way because link locals are not routable, right? So that means, hey, whether you're on this segment, you can have FE80:1 as your link local. You also can have FE80:1 as your link local down on this side. Now, you cannot have duplicate link locals. So if you had link local FE80:1 up here, you cannot have a duplicate link local down here. It needs to be unique, right? So that also means when you're configuring this side here, you're probably going to see something like link local address down here. Do not put the link local FE80:1. Don't put that up there. On a host, it has to be unique. Okay. The only place where the link local goes in is the default gateway, IPv6 gateway. It does not belong up here under LLA. So keep this value, keep it unique. Okay. All right, so that's IPv6 only. Last IP here. 10.10. What's the last IP? Remember, it summarizes 4 Class Cs. So third octet is 20, 21, 22, 23. So we got 4 Class Cs right there. So it's 23, 254. Okay, DNS server is going to be this one out here. 10, 10, 11, 254. It's 11, 254 because the /23 is going to summarize 2 /24s. Okay, that means it's 10 and 11. Okay, so now that these are directly connected, okay, and then 10, 10, 11, 254 is the DNS. We're also going to do static IPv6 here. /64 and the IPv6 default gateway is FE80:1. IPv6 address, it's of itself there. Okay, so that means for our services, okay, tick that on, abc.com 11254. We're going to add that. Here's what else we're going to do. We're going to add a second record for IPv6 DNS. IPv6 DNS, these are technically called quad A records. For IPv4 DNS, it's a record, right? Okay, so I don't know, www.6.abc.com. It's going to be 20AB 10 10 10 254. Okay, so it adds those two records there. Okay, now let's bring this link up. Okay, this one here. So now that we know EUI64, and now that we know Slack works, and that we have IPv6 more than likely configured correctly, now we could drop in okay, link local address, keep that value there. Okay, IPv6 default gateway, FE80:1. And the DNS, 20AB 10 10 10 254. So now, hopefully, we can ping abc.com. Oh, we're going to be able to ping it from this side. This is IPv4 only. Okay, so there's abc.com there. Now, from this side, this is IPv6 only. So just ping www.6 abc.com. And you should see replies. Isn't that cool? All right. So this should be E000. Should be. Okay, so why don't we make the core router .1, .2 for LA up here. Okay, we'll do .1 for all of the interfaces on the core router. Oh, since we're also doing IPv6, we got that to do now. So that's 2 and double colon 2. A description is linked to core IP address 10.10.30.2. Okay, and also IPv6 address 20AB 10.10.30.2/64. Okay, and we will no shut that. Oh yeah, IPv6 unicast routing. Okay, the LA here's our template here. LA 2811. Okay, IPv6 unicast routing, got that turned on there. And 1030.1. Okay, IPv6 address 20AB 10.10.30.1/64. And this is 2 as our link local, right? Link local, what we decided on, 1, 2, 3, and 4. Okay, so no shut that. And now we should be able to ping right, the next neighbor there as well as 30.2. We better. Okay, cool. Let's get the other side configured. Ten 2030.1 and IPv6 address. Okay, that's that. Link to SF. 1030.30.1 IPv address 20AB 10.30.30.1/64. FE80:2 is our link local. Okay, so we'll no shut that. And then have that ready for all the spokes to come online here. Yeah, WAN engineer is configuring all the transit links and goes, okay, I'm done. Okay, so San Diego, SD. Make sure the router's turned on. Okay, paste that in. SD 1841. Okay, I'm pretty sure it's this one. Yeah, it's that one. So we'll do description, link to core, IP address 10.20.30.2. IPv address 10, 20, 32 /64 IPv address FE803 as our link local, and we'll no shut. How about we'll do link to core, right? Okay, hopefully we can ping 10.20.30.1. So remember the ARP table. Do show ARP, where you see the layer 3 to layer 2 mappings and what interface it's coming in off of. For IPv6, show IPv6 neighbors. Right, there's no neighbor yet because we haven't configured anything yet. Okay, so since we pinged there, we have layer 2 address, and it's off of F00. It's off fast Ethernet 00. And here is the layer 3 address. Okay, cool. FAST1 description is linked to users. In 2020.1. Okay, so this is a /22 IPv address 2021 /64 1 2. This should be 3 as our link local. So we'll no shut that. We start to see it come up online. Okay, so this one is the IPv4 only. So that's 10, 20, 20, what? 23. Okay, and the DNS is over here. Okay. And yes, we could ping our default gateway. Last portion here is the other side. Other side here. Okay, that's our link to users, LA 2811. Okay, do show run. Yep, 10, 30, 30. And then the 20AB 10, 30, 30. Okay, good. Okay, tick the router on. Hostname SF1841. Okay, so in this case, we did F01. F01 is up here. Okay, this one's F00. Yep, so we're there. This is our description, link to core, IP address 1030.30.2. Okay, our IPv6 address 20AB 1030.30.2/64 as our link local, and then F00 description is link to users. Okay, IP address 1030.20.1. IPv address 1030.20.1/64 IPv address FE804 is our link local. Okay, so with this one, hopefully we get, yep, IPv6 auto config. Request is successful there, so it means we got something right. 20AB 1030.20.254/64 FE804 is our link local. Okay. Yeah, we'll still need an IPv4 on our switch. So nothing's changed on that. Hostname SF2960, IP address 1030, 23.253. Interface VLAN 1. Okay, then no shut, IP default gateway 1030.20.1. Okay, so good. There's our IPv4. Be sure to label the switch. Be sure to label the PCs. Okay, now we got everything configured there. Configure routing now. So you are going to need a route. Let's just take inventory here. 10.10.20.0. Right, IP route 10.10.10.0. And 10.30.0. Uh, 10.20.30. right? That one's a /30. Ten 2020. Can we also have 10/30/30? And we also have 10/30/20.0. We also have IPv6 routes to do. Okay, so let's just do 20AB, 10, 10, 20. That's a /64 there. And let's see. Then we're going to specify the next hop then, right? So it's right. Right. So your syntax is this IPv route. Right. And then IPv6 address of next hop. Right. So that's your syntax there. So we got 10/10/20. We also have we know that they're all going to start at least with that. So 10, 10, 10. Okay. IPv route 10, 10, 30. Okay. IPv route 10, 20, 30. IPv route 10, 20, 20. IPv route 10, 30, 30. Okay, and IPv route 10, 30, 20. Okay, so there's your template. So like I was saying, it's easy. It's just IPv4 routes and IPv6 routes. So if you know how to do the IPv4 routes, IPv6 way easier, right? And I hope you're seeing that. But this was also I was kind of hammering on assignment 4 last time, because for assignment 4 you need to have those fundamentals down pat in order, because this assignment 6 builds upon 4 right there. So good. From this router's perspective, okay, I'm just gonna copy that. But from this router's perspective, it is not concerned about 10/10/20. So it's not concerned about that. It's not concerned about 20AB, 10, 10, 20. Right, so not concerned about that. It's not concerned about 10, 10, 10. Right, 10, 10, 10, 0. It's not concerned about 20AB, 10, 10, 10. Okay. It's also not concerned about 10, 10, 30, because that's directly connected. Okay, directly connected. So we just need routing for the rest of these networks here. And the address is going to be 10, 10, 30.1. Okay, that's for V4 and for V6. Right, that one is 20AB, 10, 10, 30, double colon 1. Okay, that makes sense? Let's paste it in. Okay, good. Good, good, good. To show IPv4 routes, show IP route, so you remember that, right? Now for IPv6, show IPv route. That gives you routes in IPv6 here. So here's our static routes. To get to this network, go to this next hop, IPv6. Okay, so good. Okay, reset. Okay, let's look at, let's get the core router going. So the core router has 10, 10, 30, so it's not going to be too concerned with that. 10, 10, 30. It also has 10, 20, 30, which is this one, 10, 20, 30, and 10, 30, 30. Right, 10, 30, 30. 20 AB, 10, 10, 30. Not concerned about that one. 10, 20, 30. 10, 20, 30 is this one. And 10, 30, 30. Okay, so from this router's perspective, to get to 10, 10, 20, its next hop IP, 10, 10, 30.2. Okay, from this router's perspective, to get to 10, 10, 10, 30.2. Okay, to get to 10, 20, 20, which is, yeah, it's this line here. Next hop IP, 10.20.30.2. Okay, to get to 10.30.20, we need to go out 10.30.30.2. Okay, so just do the same thing for IPv6. Right, 10.10.20 goes out 10.10.30. 10.10.30, :2. To get to 10.10.10, it's 10.10.30, :2, right? Because it's this router up here. To get to 10.20.20, 10.20.20 down here, we go through 10.20.30.2, or :2. Okay, and then to get to 10.30.20, 10.30.20, we go through 10.30.30, :2. Okay, does that look all right? I hope it's correct. If not, we'll find out soon. Okay, paste that in. Okay, cool. San Diego router perspective now. Okay, we're gonna look for that and replace it with nothing. Okay, from SD perspective, it's a stub router. So this is gonna be easy work for us. 10.20.30.1. Okay, so this is going to be 10.20.30.1. Okay, 10.20.30.1. It is not concerned about 10.20.20, so that's directly connected, and 10.20.30. Okay, so not concerned about that. Uh, 10.20.20, 10.20.20. Not concerned about that. Okay, 20 AB, 10.20.30. 10, 20, 30, 1. So everything here. Yeah, I know that getting this one set up for the next one. Okay. So there we go. Okay, this is San Diego here. All right, IPv4 and IPv6. Replace. Okay, this is our next one, which is SF. So to get to every route there, well, let's find out what it's not concerned with, which should be 103020, 103020 there, and 103030. Okay, 103020 and 103030. Okay, and let's look for 102030.1. Let's replace it with 103030.1. Okay, so that's all replaced there. This next hop IP is going to have to change too. Okay, and this is going to be replaced with 20AB 1030 30 :1. Okay, so this should be the SF routes. Okay, good. So now we should be able to ping around. Okay, this should be 10, 10, 23, 254. Okay, default gateway 10, 10, 20.1 DNS is what? 10, 10, 11, 254. Okay, IP 20AB 10, 10, 20, 254 /64. Default gateway FE80:1 DNS 20AB 10, 10, 10, 254. Okay, so hopefully hopefully we can, so if we can, we'll troubleshoot. Ah, maybe that's why. 10, 30, 20, or 23, 254. 10, 30, 20, dot 1, 10, 10, 11, 254. And now let's try. Okay, it looks like we get all the way through. So cool. PC2, yep, we got our config here. So we should be able to do a trace route to 20AB, 10, 10, 20, 254. Okay, and we get what looks like a little bit of a loop there. Okay, so it gets out to 10, 30, 20. 10, 30, 20.1. So let's see if we have a route up here. Okay, and yes, we do have a route. So it's going to 10, 30, 30. Okay, 10, 30, 31 comes up here. Okay, 10, 10, 20, 254. Okay, 10, 10, 32. Okay, so it goes up to here. Show IPv route. 254. Okay, so it's connected. So now we know the forward route works. So let's just see now if there's a reverse route or if there's a return route. Show IPv route for 20AB, 10, 30, 20. Okay, so here, 20AB, 10, 10, 30, double colon 1. Yep. So we do see that. Just make sure then. Okay, this is going 20AB, 10, 30, 32. Yeah, it should be able to see that then. 10, 30, 20, 0. Okay, let's do simulation mode and see where it dies. Oh, I think we have to go ICMP v6. ICMP v6. Okay, there's the echo message. Default gateway is not set, so the packet's dropped. I wonder if might be doing this from the wrong PC. Yeah, wrong PC. Let's try it from here. Yeah, definitely wrong PC. So we'll do that from sim mode there. Okay. So there, it makes it out, goes down to the wire there. Okay. Goes up to the switch, goes up to the router. Okay, goes up, forwards up to the router there, forwards up, forwards out to the switch. Okay, yep, wasn't meant for that one, but it was meant for this one. Okay, so here's our return. Okay, here's our return there. Then return. Okay, so I guess that's working okay. But yeah, you see how you use the sim mode to help you troubleshoot. So thank goodness for sim mode there. Let's see if we can get to the DNS server. This should be 11.254. Subnet mask is 254. Default gateway 10.10.10.1. DNS. Okay, then IPv6 is 20AB 10.10.10.254. And the DNS is set to 20AB 10.10.10.254. Okay, so this one's the IPv6. So let's see if we can ping 254. Ah, too many digits there. 10.10.10. 254. Okay, so we're getting that. We should be able to also ping www6.abc.com. Okay, so far so good. So that's our IPv6 only PC. Yep, www.abc.com, looking good. Okay, this should also be able to ping over here, which should be 20AB 10.30.20 254. And if not, then we'll fix it. Okay, so let's go to sim mode here. Filter on ICMP v6. Try to follow the packet. Okay, so the packet's right there. Source IP address not specified. Default gateway is not set. Drops the packet. Yeah, that'll do it. 20AB, 10, 20, 20, 254. And then this is FE80, see, 1, 2, and 3. Right? And the DNS server, 20AB, 10, 10, 10, 254. Okay, let's try it again. Okay, much better. Much, much better. Okay. All right, I think that should do it. That should do it for getting 100 points up here. 100 points, that means you should be able to telnet all these switches too. And then also finish up the labeling here too. 10, 10, 23, 253. Ah. Hostname LA 2962. Int VLAN 1, IP address 10, 10, 23, 253. Okay, we'll no shut that. IP default gateway 10.10.20.1. Okay, now let's try it. Yep, much better. Okay. So let's just make sure switches are configured here. Host name is LA2960. Okay, int VLAN 1 IP address 10.10.11.253. Okay, we'll no shut that. IP default gateway 10.10.10.1. Okay, so this one was 11. Okay, good. Making it there. Let's go to here. Okay, paste here, SD 2960. The address 10.10 or 10.20.23.254. And no shut. Oh, yep. IP address 10.20.23.253. Okay. So that's the message that you're going to get if there's a duplicate IP address detected here. Right. IP default gateway 10.10.20.1. Okay, and this one was telnet 10.30.23 to 53. Okay, think we're good. So yeah, just finish up the labeling here, and this will get you 100 points. Okay. Yeah, Josue. Okay. All right. So here's 100 points there for you. Good luck, have fun, and we'll have the video for you after this.